Okay, so our objective today is to understand and, apply the process for adding and subtracting in scientific notation. The big difference for adding and subtracting is that I have to have the numbers have the same exponent on the base of 10, otherwise I can't consider the numbers to be in the correct place value. And that's what's important with adding and subtracting with decimals, is I have to deal with place value. So that's huge, because we didn't have to deal with that with multiplying and dividing. So it's a whole different set of rules to follow. So let me give you an example of a problem, and we'll talk about how did we go through it, and then we'll write the steps down. So I want you to take 7 times 10 to the second power, and I want you to add it to 15 times 10 to the third power. Now, what you should notice is that the exponents are not the same. One is a 2 and one is a 3. Okay? In order for me to do math, they have to be the same. So, this is, and I've watched lots of videos and I've read lots of different ways, and there's two major ways to do it, and I'm going to share with you the one I think is the easier way. And I'll tell after we do it why I find it to be the easier way, okay? So what you want to do is to locate the smaller exponent. So of those two, which one has the smaller exponent? Yeah, to the second power, right? 7 times 10 to the second. So what we're going to do is we're going to rename him. We're going to need to rename him. So notice this is what 7 times 10 squared equals. Okay, it's actually 7 times 100, or it's 700. But what I need it to say is to the third power. So I need to somehow figure out how I can get this to become this. Okay. So if you think about it, I'm taking 7 times 10 squared, and I want to make it 7 times 10 cubed. But 7 times 10 cubed can't equal 7 times 10 squared. So what did I do to 700 to make it 7,000? Okay, which is multiplying it by what? To add a 0. I just multiplied it by a 10. Okay, so if I have 7 times 10 squared, and I multiply it by 10, what I'm going to get is 70. Okay, or a point, I would get, let's do it this way. In order to get this to match up, I'm now going to change my actual number. So if you think about it, okay, I want this value to have, oops, not supposed to erase. There we go. I want this value not to be a different value from him. I want him a way to rewrite so my answer has to the 7th. So if I want to rewrite to the 7th power, let's see what my two options are. If I wrote 70 times 10 cubed, that would give me 70,000. Is that the answer that I need? No. That's way too much. So it's not going to be that. What if I did 0.7 times 10 cubed? If I move the decimal point over once, twice, 3 times, do I get what I started with? Yeah. So notice what I had to do with this original guy. In order to increase the exponent by 1, the trade-off is I had to move the decimal point left by 1. Okay, Jonah, I need you watching. All right? That's the trade-off. To increase the exponent, I got to do an opposite. I got to decrease where the decimal is. So I got to move it to the left. So if I'm increasing by 1 decimal place, I got to decrease by 1 decimal place in my number. Okay? So here's what my problem now looks like. 0.7 times 10 cubed plus 15 times 10 cubed. Now notice that 15 is not written in scientific notation, but that's okay for our purposes. Now we can deal with that. So now what we do is we take the decimal values and we're going to add them because that's what the operation tells us to do. And we have a matching exponent. So we're not actually in our answer going to change the exponent. We just bring it along. Okay. So what's 0.7 plus 15? Well, remember how you have to work this? You have to line up decimal points in order to add or subtract, especially with subtracting. So this gives me 15.7 times 10 cubed. So just like we talked about with multiplying and dividing, do we need to make an adjustment on our answer? Yes. Yeah, our answer is above 10. We need it to be between 1 and 10. So my number is considered what kind of number? Small or large? Large. And that's because I see numbers first, I don't see decimals. So what kind of exponent do we associate with a large number? Positive. So I needed to move the decimal point a positive 1. So my final answer is 1.57 times 10 to the 4th power. Okay? So let's go back and we're taking notes, Summer? So you need to take them as well. So let's go through the process. The exponent on the power of 10 must be the same to add or subtract in scientific notation. That's rule number 1. If they are already there, bam, all you do is math with the decimal part and the variable and its exponent will stay. Not the variable, but the base of 10. Yes, ma'am?
Exponents of
To scientific notation. Yes. So if you have one that's times 10 cubed and one's times 10 to the 5th, we've got a problem. It won't work. Okay? Jacob?
The ones on our, some of the ones that are on our homework, we're just going to have to add and subtract. So
I don't know. I didn't memorize the questions we have on homework, so you'll have to wait and see. Okay? So you have to pay attention to details. That's going to be the tougher thing tonight, is paying attention to the details. 2, if the exponents don't match, which most likely will be the case, we have a protocol. So we're actually doing what I like to call is prep. We're prepping the problem to do the math. Okay? And if we don't do the prep, we can't do the math. So if the exponents don't match, first you're going to select the value with the smallest, or smaller I should say, exponent. Now in the example we had, there was a difference of 1. You may have examples where the difference is more than 1. It just depends upon what those exponent numbers are. Okay? Jacob?
Could you just keep the bigger exponent and then change it all at the end or no?
No, you can't. Because they would not, place value would not line up. That's why the exponent has to match, because now we're changing place value. So select the value.
Grant, please report to the office. Matthew Grant, to the office.
We select the value with a smaller exponent. We're going to move the decimal left as many places as it takes to make the 2 exponents the same. So we're going to be moving left all the time. We're going to create a lesser number with a higher exponent. Okay. So if you take a penny, 1 penny, but you write it in terms of dollars, it now becomes less, 0.01. So when I change it to a larger label, I end up getting a smaller number. And that's the same idea that works here. Okay, kind of an inverse relationship.
So you'd have to like change the thing, because then it would make like a smaller number, but then like.
Right, yeah, you came up with the idea if we used a different label, a larger label, then we'd end up with a smaller number. And that was a way to get around trying to find all these small numbers, okay? So again, we select the value with the smaller exponent, and we're going to move the decimal left as many places as it takes to make the two exponents the same. So we're going to rewrite the value in scientific notation with now matching exponents. And when I'm talking about matching, I'm talking about with the other value. Okay, so now we just set up the problem. Now we're actually ready to do math. Step 3, oops, sorry, go back to black. We're going to add or subtract depending on the operation. So the operation between the two scientific notation will tell us what math to do. Add or subtract the decimal values. Now you're going to have to follow decimal rules. And decimal rules in adding and subtracting say you must line up decimal points. You must add zeros. If one number is shorter than another, you need to add zeros to make them the same length. You must rename as you need to, especially with the subtraction. I have a lot of kids who don't do that, and they get the wrong number. They just bring a digit down. So we'll do some. We'll make you do that. And you need to make sure that the decimal stays in its location. It doesn't get to shift anywhere. Okay, so add or subtract the decimal values. And this time, not only do we keep the multiplication and the 10, we also keep the exponent that they have in common. So I'm going to say the exponent that is now the same. So the real math gets done in the prep and then in a little adding or subtracting problem. We don't deal with the exponents at all. The last thing we may have to do is adjust the answer if necessary. And remember, that just means if the number is not between 1 and 10, we're going to have to move the decimal point to make it between 1 and 10 and adjust the exponent as necessary. Okay, so let's do a couple. We'll do another adding problem, and then we'll do a subtracting problem so you can see both of those. So, all right, so let's do, the directions are just going to say add or subtract. Keep in scientific notation. So if on the test you decide, forget it, I'm not going to do this, I'm going to go ahead and change them to standard notation and then have the answer back into scientific notation, I can't give you full credit. Because again, I want to see that you can do the math in scientific notation. So let's do 5.7 times 10 to the third. And I want to add to that 1 times 10 to the fourth. So our first step is to look and ask, do we have the same exponent? Yeah. And the answer is no, we don't. So then we identify which one has the smaller exponent. the 5.7 times 10 cubed, and he's the one we're going to do a little alteration on. In order to get the exponent to change up by 1, we're going to have to move the decimal left by 1. That's what our process said. So we needed to get up to 4. That means we have to go the other direction, the opposite direction. We're going to go left. So what we have now is 0.57 times 10 to the 4th plus the 1 times 10 to the 4th. So now we grab out the decimal parts, the 0.57 plus the 1, and we keep the times 10 to the 4th. Okay. Now you can line up decimal points. I'm going to do this over to the right. And we get 1.57. And then times 10 to the 4th.
So you don't do anything to exponents?
Exponents do not change. It's like saying 2x plus 2x is 4x, not 4x squared. We don't change the exponents in an adding or subtracting. Now, my answer was fine because it met the criteria, so there was no adjustments necessary on that one. Okay? All right, don't give up. We're not done yet. We still have more. Don't sit there and whine. I get 5 more minutes of your time. Okay, ready? Okay, next problem. Let's do 2 times 10 to the 7th power. And I want to subtract from that 4 times 10 to the 6th power. So do my exponents match? No. Which one has the smaller exponent? So what we're going to do to get the exponents to match is we're going to add 1 to 6 to get to 7, and we're going to move the decimal point left once. That's going to give me 0.4 times 10 to the 7th power. Now I didn't have to do anything to the one whose exponent we were trying to match. He stays exactly the same. So now what I do is I grab the decimal parts, and I have 2 take away 0.4, and then the times 10 to the 7th remains the same. So off to the side, I do 2.0 take away 0.4. Line up the decimal points. I have to rename, and I get 10 take away 4 is 6, and 1 take away nothing is 1. And I get 1.6 times 10 to the 7th. So my resulting decimal meets the criteria for scientific notation, so there's no renaming that needs, no adjusting that needs to go on. All right, let's do one more. All right, let's see. Let's do... Let's do this one, last one. 8 times 10 to the 3rd minus 1.3 times 10 to the 5th. Oops, sorry. I don't know why I did that. Okay. So do my exponents match? No. Which one has the smaller exponent? Bailey? Which one has the smaller one? First one. So what do I need to do to the exponent to make it match? Summer? Okay, and how many places am I going to move it though?
Twice.
Yeah, it's going to take 2 from 3 to get to 5, so I'm going to have to move the decimal point over twice. So that creates 0.08 times 10 to the 5th minus 1.3 times 10 to the 5th. So now I have 0.08 take away 1.3 times 10 to the 5th. So off to the side. Ooh, this is weird. Ooh, what am I going to get for my answer on the decimal part, Joe? A negative, because I have more on the negative side. But when I do the actual subtraction, I do need to put the bigger number on top. Now, this is where a lot of kids forget the 0 and then they bring the 8 down, but that's not what this problem says to do. So decimals in the answer. I get 10 take away 8 is 2. 2 take away 0 is 2. And then I have a 1. So the answer, because this guy was negative, I get negative 1.22 times 10 to the 5th. Again, my answer did not need any adjusting.